Hello everyone, welcome to the Bharat Academy. I am Manoj Thapliyal and today's topic is chi-square test. Students, before starting chi-square test, it is better to understand where do we use this chi-square test. In agriculture as well as the biological researches, apart from the quantitative data, one has to deal with the qualitative data such as seeds color, flower color, hair color, eye color and male-female birth. In such cases, the observations are classified in a particular class, category or group. Students, the observations which falls in different classes, one has to calculate the expected values to find the deviation between expected frequency and the observed frequency. Now in all the genetical studies, we test the significance of overall deviation between the expected frequency and the observed frequency, and this test significance of this deviation is known as chi-square test. And the chi-square test is a useful measure of comparing the experimentally obtained results with those expected theoretically based on the hypothesis. As we have just discussed, in agriculture as well as the biological researches, apart from quantitative data, one has to deal with the qualitative data like flower color, seeds color, hair color, eye color and male-female birth, in which the observations are classified in a particular category, class or group. If the observations fall in a class, then one has to calculate the expected values to find the deviation between observed and expected frequency. Now the definition of chi-square test, it was developed by a statistician Carl Pearson in 1900. This chi-square test was first used by Carl Pearson. Carl Pearson in 1900. It is defined as chi-square equal to summation FO minus FE its whole square upon FE, where this FO is observed frequency. That is the actual frequency obtained from experiment, and this FE is your expected frequency, also called theoretical frequency, which are obtained by probability theory. As we know, there are three types of theoretical distribution. First is binomial, second is Poisson, and third is normal. So this expected frequency we can calculate from binomial distribution, Poisson's distributions and normal distributions. Now student, we discuss the properties of chi-square distribution. This is the curve of chi-square distribution. First property is chi-square test is positively skewed. Positively skewed means its curve is always inclined in the positive direction. And the second one is the mean of the chi-square distribution is equal to number of degree of freedom. And third one, chi-square value increases with the increase of degree of freedom. As degree of freedom increases, the value of chi-square also increases. And the next one, standard deviation of chi-square is root 2 nu. Nu means degree. Here this nu is degree of freedom. And the next, the value of chi-square lies between 0 and infinity. This chi-square value always lies between 0 to infinity. And the sixth property is for the different degree of freedom, the curve will be different. And the last one is the sum of the two chi-square distribution is again a chi-square distribution. Now student, these are all the properties of the chi-square distributions which you have to keep in your mind. Now student, let us discuss degree of freedom. There you can find degree of freedom in two ways. First is, if the data are given in a series, then degree of freedom can be calculated by n minus 1, where n is the number of observations. And in second case, if the frequencies are put in a cell, of a contingency table or matrix table, you can call it contingency table, then degree of freedom you can calculate from this formula, r minus 1 into c minus 1, where this r is the number of rows and c is number of columns. And now we discuss the uses of chi-square distribution. There are three uses of chi-square distribution. First is the test of goodness of fit. Second one is the test of independence of attributes. And the last one is the chi-square test for homogeneity or test for comparing the variances. Now we take the first use of chi-square distribution, which is test of goodness of fit. First use of the chi-square distribution is the test of goodness of fit. In the chi-square goodness of fit test, the term goodness of fit is used to compare the observed sample distribution with the expected probability distribution, or in other way you can say it like this: it is used to test whether there is any significant difference between the expected frequency and the observed frequency of the distribution. It shows whether the deviation between the observed value and the expected value are by chance or some other factors. Now, I take the example based on the goodness of fit. The question is, in a Mendelian experiment on breeding, 4 types of plants are expected to occur in the ratio 9:3:3:1. The observed frequencies are 891 round and yellow, 316 wrinkled and yellow, 290 round and green, and 119 wrinkled and green. Find chi-square and examine the correspondence between theory and experiment. As we have already discussed in the last video, there are certain steps in testing a hypothesis. First step is null hypothesis. You have to form the null hypothesis, which is denoted by H0. In the goodness of fit test, we always take there is no association between the given observed and expected frequency. Same I have taken, there is no association, there is no difference between the observed and expected frequency. Now the alternative hypothesis is there is a difference between observed frequency and an expected frequency. Next step is calculation of chi-square. As you know, the formula for the chi-square is summation FO minus FE its whole square upon FE, where FO is your observed frequency. The observed frequency in the questions are given 891, 316, 290 and 119. The total frequency will be, add all these observed frequency, you will get 1616. And this is also given in the question, 4 types of plants are in the ratio of 9:3:3:1. The total ratio will be 9 plus 3 plus 3 plus 1, this is 16. From these calculations we can calculate expected frequency for this data. The first expected frequency for round and yellow will be total frequency into its part is 9 upon total ratio, that is 16, this is 909. Second, wrinkled and yellow, total frequency 1616 into its part. Second part is 3 upon 16, this is 303. third round and green, total frequency 1616 into third 3 upon 16, this is 303, and the last one wrinkled and green 1616 into last part was 1 upon 16, this is 101, and these are your expected frequency, and these then the given frequency were the observed frequency. On the basis of expected and observed frequency, we form this table. This is round and yellow, this is wrinkled and yellow, this is round and green, this is wrinkled and green, and all these are given. Observed frequency were given 891, 316, 290 and 119. Expected frequency, we have already calculated all these things. FE 909 is there, 303 and 101, and then we find the deviation between observed and expected frequency. Deviation means difference, FO minus FE. Just subtract these two numbers, you will get minus 18, here you will get 13, here minus 13, and then last the deviation is 18. Next one, square of the deviation, FO minus FE, it's a whole square. The square of minus 18 is 324. Its square is 169. Here this is 169, and the square of the 18 is 324. This is the square of their deviation. Now our formula says the chi-square is summation FO minus FE its whole square upon FE. Here I have calculated FO minus FE its whole square upon FE. It will be from here 324 divided by FE. FE is our 909. It is 0.3565. Similarly, 169 divided by 303. This is 0.5578. 169 divided by FE. FE is here 303. This is 0.5578. And the last one, the FO minus FE, its whole square is 324. It is divided by FE. FE was 101. You will get 3.2079. And calculate all these values, you will get 4.6799. This is the value of summation FO minus FE, its whole square upon FE. Actually, this is nothing but value of chi-square. So here, the calculated value of chi-square cal, we have calculated. This is summation FO minus FE, its whole square upon FE. It was 4.6799. This is your chi-square value from the formula. Next step is in hypothesis testing. You have to find the degree of freedom. Degree of freedom. For the goodness of fit test, the degree of freedom will be n minus 1. N is the number of observations. Number of observations we have 1, 2, 3, 4. So n will be 4. Hence the degree of freedom is going to be 4 minus 1. This is 3. Now next step in the testing of hypothesis is level of significance. Fourth step is level of significance. Significance. In this question, level of significance is not mentioned. Since level of significance is not given, so then we take level of significance alpha equal to 5%. Level of significance is equal to 5%. Now what we do? Fifth step is for given degree of freedom, which is 3, and level of significance alpha, that is 5%. We find the value of chi-square from the chi-square table. This is chi-square at 3 degree of freedom and 5% of level of significance is given 7.80. Chi-square 7.80. So this is called tabulated value of chi-square, or this is also called critical value of chi-square. Critical value of chi-square, and And the last step is we compare this calculated value and the tabulated value. Chi-square calculated value is, how much is this? 4.6799, and tabulated value, chi-square tabulated value is 7.80. So it's quite clear that calculated value is less than chi-square tabulated value. So if the calculated value of chi-square is less than tabulated value of chi-square, it means the null hypothesis H naught is accepted. That is, there is no difference. No difference or no association between observed frequency and expected frequency. So this is your chi-square test in case of goodness of fit. Now the student's second applications of chi-square is test of independence of attributes. Attributes means qualities. The chi-square test can also be applied to test the independence between the attributes when the sample data are presented in the form of contingency table with any number of rows and columns. Example, if the contingency table is like this, in this contingency table, there are two rows. This is first row and this is second row, and these are called columns, first column, second column and third columns. So this is called contingency table. If the sample data are given in this contingency table, these are called cells. If the frequencies are put in the cells, then in this case degree of freedom is given r minus 1 into c minus 1, where r is the number of rows and c is the number of columns. And in this case, the expected frequency can be calculated by this formula. Expected frequency Fe will be Ri into Ci upon n. Ri means ith row, Ci means ith column, and n is the total frequency. So from this formula we can get expected frequency, and observed frequency will be given in the question. Now we take the example based on the independence of attributes. The example is, the following table gives the classification of sample of 160 plants of their flower color and flatness of leaf. Now the table is flat leaves, colored leaves, white flower, red flower, and the data are 99, 36, 20 and 5. We have to find the test whether the flower color is independent of flatness of leaf, and it is given in the question. The value of chi-square for 1 degree of freedom and 5% level of significance is 3.841. Now, as you know, in testing of hypothesis there are certain steps. Again, we have to follow those steps. First one is null hypothesis. Null hypothesis H naught. Null hypothesis in this case will be that there is no association between flower color and flatness of leaf. Yeah, there is no dependency of flower color on flatness of leaf. The null hypothesis will be there is no association between flower color between flower color and flatness of leaves. Flatness of leaves. We take it from here. Now this is the null hypothesis, and alternative hypothesis based on this null hypothesis will be there is an association. There is an association between the flower color and flatness of leaf. Flatness of leaves. This was the first step in hypothesis testing, and the next step is to find the calculated value of chi-square. And for this, for the value of chi-square, you have to find observed frequency and expected frequency. The frequencies given in the questions are always observed frequencies. These are your observed frequencies. Now we have to calculate the expected frequency based on these observed frequency. Now we calculate the expected frequency. Now on the basis of these observations, on the basis of this data, which is for the observed frequency, we can calculate the expected frequency. Expected frequency will be like this. Formula for the expected frequency was Ri into Ci upon n, grand total. For this, you will have to find this data, original data. Just calculate the first row, 99 plus 36, this is 135. Addition of second row, 20 plus 5, 25. And calculate the total of the first column. First column is 99 plus 20, this is 119. 36 plus 5 equal to 41. From this table, it's quite clear what are the values of R1, R2, C1, C2. R1 means total of first row. R2 means total of second row. C1 means total of first column, and C2 means total of second column. Now on the basis of R1, R2, C1, C2, and n is the grand total. Here in this case, n is 116. For the expected data or expected frequency, we have to form another table. In this case, the first shell F1 will be R1, first row. This is your first row and the first column. The formula will be R1 into C1 upon n. What was the R1? First row total 135. C1 was 119 upon total 160. This is 100.41. And the Fe for the second shell lies in first row and second column. First row means R1 and second column means C2 upon n, grand total. This is 135 upon, this is 135 into 41 upon 116. This is 34.59. And the expected frequency for the second row. For this cell, Fe will be R2, second row, and this is first column. R2 into C1 upon n. The values 25 into 119 upon 160. This is 18.59. In this case, this lies in second row, but this is second column. Formula will be R2 into C2 upon grand total. 25 into 41 upon 160. This is 6.41. It's quite clear that we know the values of observed frequency and the values of expected frequency. On this basis, we can calculate chi-square value. Chi-square is summation Fo minus Fe, its whole square upon Fe. Now we calculate this by another table. Now students, we start the third table. These are your FOs, means observed frequencies. These are expected frequencies. Then you have to find the deviation, means difference between these. 99 minus 100.41, this is minus 1.41. You can calculate all these deviations. Then their squares, Fo minus Fe, its whole square, minus 1.41, its square is 1.99. Similarly, square of these values are given in this column. Now the last one, we have to find Fo minus Fe, its whole square upon this Fe. So this value is first is 0.019, 0.107, 0.056, 0.3, 0 and add all these values. This is 0.492. This is the summation of FO minus FE, its whole square upon FE. Actually this is your chi-square value, means calculated value of chi-square. The chi-square calculated value is 0.492. This was your second step in hypothesis testing in this question, and the third step is degree of freedom. And in the case of independence of attributes, degree of freedom, as I have already discussed, this is R minus 1 into C minus 1. In this question, number of rows were 2 and number of columns were also 2. R means number of rows, and in this question number of rows were 2 and C number of columns, this were also 2. So from this data you can find degree of freedom 2 minus 1 into 2 minus 1. This is 1 into 1, this is 1. So this is your degree of freedom. Now again, level of significance is not mentioned. The level of significance, if not mentioned, generally we take alpha equal to 5%. Level of significance, alpha is not given, so we take alpha equal to 5%. And the fifth step in the hypothesis testing, it is given in the question, if for 1 degree of freedom and level of significance, alpha equal to 5%, the chi-square value was given, chi-square 1 comma 5% was given 3.841. This is your tabulated value. Now last step is we have to compare these two values, calculated value of chi-square with the tabulated value of chi-square. In this question, calculated value is 0.492 and tabulated value we have just checked, this is 3.841. It's quite obvious that this value is less than tabulated value. If calculated value of chi-square is less than tabulated value of chi-square, it means the null hypothesis is accepted, and it means there is no association between color of flower and flatness of leaves. Now students, the third application of chi-square test is chi-square test for homogeneity or chi-square test for comparing variances. In 99% cases, the chi-square is used as a non-parametric test since it is not derived from the population observations mean ST. But in 1% cases, it is used as a parametric test since in this case we compare the variances of sample and variances of population. Only in 1% cases it is used as a parametric test. In 99% cases the chi-square test is used as a non-parametric test. Parametric test. Since it is not derived from the population observations, but in 1% cases it is used as a parametric test. Parametric test. When it is used to compare the sample variances with population variances. In this case, the chi-square test is given as chi-square equal to n minus 1 into s square upon sigma square, where s square is the sample variance, variance of sample, and sigma square is population variance, where n is the sample size. Now we take an example based on the chi-square test of homogeneity. Now we take an example based on chi-square test for homogeneity. The example is a sample of 30 light tubes yielded SD of 90 hours burning time, whereas the long experience with a particular brand showed SD of 105 hours. Using alpha equal to 0.05, test if there is any difference in SD or not. And this is given in your question. Peak value of chi-square at 29 degree of freedom and 5% is 42.55. Student, as you know, in every hypothesis testing, there are certain steps which we have to follow. The first step is null hypothesis. In this case, null hypothesis H naught will be, it can be taken from your question, that there is no difference in SD, and alternative hypothesis will be just opposite of this, there is a difference between SD. Second part will be calculated value of chi-square. The formula for chi-square is here, h n minus 1 s square upon sigma square. S is standard deviation of sample, s square means sample variance, sigma is population SD, sigma square means population variance. Put all these values over here. After calculation you get 21.31, and the third step is degree of freedom. And to calculate degree of freedom, you find number of observations. The formula is n minus 1, n is 30 tubes are already there. The degree of freedom is 30 minus 1, this is 29. Level of significance is given in your question, this is 0.05, this is 5%, and it is also given in your question. The tabulated value of chi-square for 29 degree and 5% is 42.55, and at the last, you just have to compare these two values, calculated value and tabulated value. Here calculated value is 21.31 and tabulated value is 42.55. So again, calculated value is less than tabulated value. It means the null hypothesis is accepted. That is, there is no difference in SD. That is, there is no difference in SD. And with this, the lecture is over. Students, if you have found this video interesting and helpful, so please like this video and subscribe my channel for more videos in future. Thank you for watching this video.